Hello again, everybody. Welcome back to a new screencast lecture. Today we're going to be talking about our atmosphere. It's our friend, and we're going to talk about why it's super important and why it's great because I enjoy being alive. How about you? Let's get started. Our learning target is that our atmosphere has many different properties. One of the properties, a very important property of our Earth's atmosphere, is that the atmosphere helps to protect life here on Earth, including you and me. Let's start with the definition of atmosphere. The atmosphere is a thin layer of gas surrounding the Earth. Let's take a look at this picture. What is this location? Where do you think this is? Yeah, that's right. This is the moon. And these moon formations that kind of give it away, what are these formations called? That's right. They're called craters. Craters, how are craters formed? Craters are formed like you see here in this picture when a meteor crashes into the surface of the planet, or in this case, the moon. Craters are holes formed by meteors crashing into the surface. This next clip is a model of a crater being formed. This is pretty neat. A metal sphere is used as the meteor, and a beaker of sand represents the Earth, or it could represent the moon or any other planet. Notice that the crater will be larger than the meteor that hit the ground. So when the meteor hits the ground, the crater is not just going to be the same size as the meteor. The crater, after it's done, will be bigger than the object itself. Not too bad. Craters may look different dependent on the material that the meteor hits. Here's a clip that shows that. Watch for that. That's pretty cool. Love the slow motion. Notice that the material from the meteor in the ground may be thrown great distances away from the crater when the meteor hits. Check this out. Pretty impressive. I think so. Now it's obvious that the moon has been hit many times. You just look at the moon, you can see craters all over the place. Crater, 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 crater. Does the Earth ever get hit? Well, the Earth doesn't look like the moon. We don't see craters all over the place on the Earth. There is evidence, however, of the Earth being hit by meteors many times in its past history. This next slide shows Meteor Crater in Arizona. Sometimes it's known as Barringer Crater. Impact was about 50,000 years ago, is the estimate. And this meteor was about 160 feet across and was traveling about 29,000 miles per hour upon impact. It was about twice that size before it entered the atmosphere. Here you can see the crater roughly about a mile across. If the object itself was 160 feet, that's just about half of a football field. It's a little bit bigger than half of a football field, certainly not a mile. The crater's relatively young age, plus that dry climate in Arizona, preserved that crater and protected it from erosion. So we get to enjoy and see it now. Here's an aerial view of that crater. Here you see the visitor center. This is kind of an odd thing in that this is not like a national park or anything like that. This is actually a privately owned attraction, I guess you could call it. I've never been there. I've had some students who have been there. Here's a clip showing Meteor Crater. It is called Barringer's Crater by these folks. These are the people that own the crater. This next slide has a picture of a recent impact crater formed on the moon. This impact occurred at over 56,000 miles an hour. The impact was actually visible from Earth with the naked eye. I certainly didn't see it, but that's what they say. And here you see it right here, kind of highlight for you against the moon. The meteor itself was only about a foot in diameter, but it made a crater about 300 feet in diameter. Wow. Here's a clip showing the impact and the resulting crater. It's sped up and enhanced, so it's not exactly real, but it's still pretty cool. Pretty impressive. That's a lot of power. So why don't we see craters all over the Earth like we do on the moon? Again, look at these. Crater, 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 crater. Lots of craters. There are multiple reasons why we do not see many craters on our Earth, but we do see many craters on the moon. The first reason is that the moon has no atmosphere, but of course the Earth does. So how does that help? Well, Earth's atmosphere will burn up most meteors before they can hit the ground. Heat is caused by friction and pressure of the meteor striking the air particles. You can imagine if you take your hands and rub them together very, very quickly, you start feeling that heat. Now try doing that at 26,000 miles an hour. A lot of speed, a lot of heat. That streak is what we call a shooting star. So if you see a shooting star, you're not really seeing a star. You're seeing a piece of rock burning up through the atmosphere. Not quite as amazing, but still pretty cool. Our atmosphere helps to protect us from dangerous meteors. That's a really good thing. How else does the atmosphere help to protect life? Let's consider what the Earth would be like without an atmosphere. Not a very, very friendly place to be. We would have extremely cold nights and extremely hot days. The moon we can use as an example. It's about the same distance from the sun as the Earth is. However, the moon doesn't have an atmosphere. The moon can get down to negative 300 degrees Fahrenheit when it's in the dark, when it's nighttime, and 214 degrees Fahrenheit in the sunshine. We don't want that. The Earth would have no weather features like wind and precipitation if we didn't have an atmosphere. That is bad too. And because there would be no weathering, there would be almost no erosion. So, for example, here's Neil Armstrong putting his foot on the moon. You could see him leaving his footprint, first man on the moon, pretty cool, from Ohio. And apparently that footprint is still there because there's no weather, therefore there's very little erosion. There is some because you do have solar wind and stuff like that. However, it's minimal, especially compared to the amount of weathering and erosion on the Earth. So let's summarize the two reasons Earth has very few visible craters. The first reason is that Earth's atmosphere destroys most meteors before they can hit. So what that means is that the moon has no atmosphere, so the moon is going to get hit more often than the Earth does. The next reason, there are more visible craters on the moon than on the Earth. The Earth has an atmosphere, and the Earth's atmosphere causes our weather. Wind, rain is going to cause erosion, and it's going to erode away most craters that are formed. So if a meteor does get through our atmosphere and does hit the Earth, leaves a big crater, that crater is going to be eroded away over time. The moon, since it has no atmosphere, has no weather, therefore practically no erosion. A crater hits the moon, it's going to stay there for pretty much ever. This next clip is a Swiggity Swag science music video called Walking on the Moon. Watch for some facts about the moon that you learned in this lecture. Fun fact about this video, this was our last video that we performed live. So when we did this song, we actually sang it live instead of recording it ahead of time and then acting out the video. So it was a little challenging to make to try to get through it without making any errors, but hey, enjoy.
Then I heard this song by this team. 1/6 of the Earth's now. Gravity is low on the moon now. Its mass is much smaller than Earth's. How slow I shall fall. The moon has no atmosphere. There's no air at all. It has no wind nor weather, no rain and no clouds.
Make it rain.
And with low tilt of its axis, no seasons or clouds. I'm walking on the moon,
Oh,
no weather on the moon,
oh,
low erosion on the moon,
oh.
great stony road on the outside, and don't feel cold on the dark side, 300 feet low on the dark side, and don't feel hot on the bright side, 260 Fahrenheit on the bright side. I'm feeling cold, I'm feeling hot, I'm feeling hot, I'm feeling cold, I'm feeling cold, I'm feeling hot, I'm feeling hot, I'm feeling cold. I'm walking on the moon.
Walking on the moon. Walking on the moon. Oh, I forgot. Bye, kids. Be careful. Bye. Bye.
All right, so great. So the atmosphere protects us from meteors. It keeps us from freezing and boiling to death. Not too bad. Those are some good things, right, folks? Is there anything else that our atmosphere does? Pretty busy atmosphere. Well, yeah, a third way that the atmosphere helps to protect life on Earth is that if we didn't have an atmosphere, much higher levels of solar radiation would hit the Earth and harm living things. For example, hard for me to say that, ultraviolet radiation may damage plants and other forms of life. For example, with people, it can cause skin cancer. Our ozone layer is made with oxygen and is really important when it comes to this ultraviolet radiation. It absorbs a lot of that ultraviolet radiation, or sometimes abbreviated UV, and helps protect us from that. UV radiation can cause damage on our skin, possibly even lead to skin cancer. We don't want that. Here you can see a picture of sunscreen versus no sunscreen. So this picture on this side, he has sunscreen on and he looks dark because the sunscreen absorbs the ultraviolet radiation versus without sunscreen, the ultraviolet radiation gets to his skin and is visible to the camera. This clip here coming up shows how sunblock helps protect our skin from harmful ultraviolet radiation. Let's check it out. While that's pretty dramatic, well, we can see that the ozone layer is very important to us and other life on Earth, and it's also super important to use sunscreen. Our ozone layer is somewhat vulnerable, though. The ozone layer, for example, can be damaged by chemicals called CFCs. CFCs stands for chlorofluorocarbons, And those chlorofluorocarbons were used in some older refrigerators, air conditioning, aerosol spray cans. We could observe damage to our ozone layer. Here you see a picture of what's called the ozone hole. This is a reduction in ozone thickness over Antarctica. Here you see a false color image that can show that the atmosphere over Antarctica has had the ozone layer damaged. The good news is, though, is that the ozone layer has been getting better, has been repairing. People have been using these CFCs less and less. All right, now we learned some stuff. Let's go ahead and do a quick review of what we've learned today. The first question is, the thin layer of gases surrounding the Earth is called, 3, 2, 1, the atmosphere. That's right. I'm sure you got that one right. Identify a way that the atmosphere protects life on Earth. More than one possible answer on this one. One good answer would be that the atmosphere may burn up and destroy meteors from space before they hit the Earth. Another possible answer was that the Earth receives thermal energy from the atmosphere, helps keep it warm at night. So the Earth doesn't get super duper cold at night like it does on the moon. And also the atmosphere helps to absorb and reflect some solar radiation that would be harmful to life on Earth. All good stuff. Why is the ozone layer important? That's right, the ozone layer absorbs and reflects some ultraviolet radiation that would be harmful to life on Earth, including ourselves. What is the relationship between the ozone layer and CFCs? Yep, you got it. The ozone layer can be damaged or destroyed by CFCs. We can see results of that by taking a look at the ozone hole found over Antarctica. All right, as we can see, the atmosphere is our friend. We need to protect it. We need to enjoy it. Helps keep us safe. Helps keeps us warm. Helps keeps us cool. Does all kinds of great stuff for us. And of course, we like to breathe it. That's all we have for today. Hopefully you learned something. If you liked it, give it a thumbs up. If you didn't like it, give it a thumbs down. Make a comment down below. And of course, you should subscribe. We'll catch you next time. See ya.